Hello everyone, welcome back to my channel, and in this video we are going to discuss some questions, the multiple choice questions from the paper of 2025. So let's discuss some of the questions. So question number 21 states radium is an element below barium in group 2 of the periodic table. Which equation shows what happens when solid radium nitrate is heated strongly? The reaction is similar to how magnesium nitrate is going to react. So if even if you don't know how this radium is going to react, just consider the reaction of magnesium nitrate. So keep in mind, whenever nitrate is going to burn, or whenever it is going to decompose, or you can say decomposition, the thermal decomposition, it will result in the formation of nitrogen dioxide. That is for very, very sure. So wherever you find the equation with nitrogen dioxide, you need to choose that. So this B and C is out of league now. Let's consider A and D. So we have to check which balancing is correct. So let's work on this first one. So there are two radium here, correct. Now how many nitrogen? The two nitrogen here outside the bracket, and then we have to multiply this as well. So there are four nitrogen and four nitrogen here. So this one is also correct. Now let's consider oxygen. So 6 oxygen here, and they're multiplying with 2, so there are 12 oxygen. So 2 here, 8 here, and again 2 here. So they are collectively 12. So this equation is correct and it is balanced. Number 22, the table shows some data from the element in period number 3. Means we'll start from sodium and enter argon. So some melting point is given and electric conductivity is given. So these are the non-metals, the phosphorus, sulfur, chlorine, argon. They are not good conductors. Silicon is metalloid, so it's not a good conductor. While these one are the metals and these are good conductors. So let's see what can be deduced from this information. Number one, which statements are correct? Number one, all the elements in the table with giant structure have a higher melting point. No, it's not correct. The sulfur also have a joint structure as well as silicon when they make a covalent bond, but these were the metallic bond where we have the delocalized electrons. So this option is incorrect. Number two, magnesium has a higher melting point than sodium because it has more delocalized electrons. Yes, it is correct. So when we make the metallic bond, so in magnesium there are two electrons in the valence shell, so there is a charge of +2. So yes, there are more electrons in the outer as compared to the sodium, which loses only one electron. So this can be correct. Number three, phosphorus and sulfur do not conduct electricity as they are simple molecular solids at room condition. Yes, they do not conduct electricity, and we know that if there is a covalent bonding, it's difficult to conduct electricity. So this option can be correct. So the final answer we can say is this D. Then move to the next one. Each mineral listed behave as a mixture of two carbonate compounds. So they can also be fire retardants. Can be used in fire extinguishers because they decompose on heating and produce this one, carbon dioxide. The gas smothers the fire. So what can be the correct order? So we'll consider this first one. So we have magnesium, calcium, and barium. So the best one which decompose easily is the magnesium one, and then this calcium one, and then the barium one. So I guess the order would be phosphohuntite, dolomite, and barytocite. So our answer would be D. Next one is compound X contains two elements from period 3 similar. It's from like sodium till argon in the periodic table. So let's say what they are saying. Compound X reacts with water to form only two products. One is slightly soluble hydroxide. Okay, so it's from the group number 1 to group number 3. So we say that the metals or the group 1 elements, they are very strong alkali, so slightly soluble is going to be ruled out. The second one is magnesium. Yes, magnesium is slightly soluble, as well as the aluminum one. So aluminum we consider it's insoluble. So magnesium, it can be magnesium, very simple. And the compound Q. Let's see what is compound Q. Q is a component of element Z. Okay, so this Q is something from the Z. Compound Compound Q burn in moist air to produce oxide and water. The oxidation state is +5. Okay. So when we move from sodium, magnesium, aluminum, here in group 5 we have phosphorus. So it can show two oxidation state, that is +5 and -3. So it can be phosphorus. So which row identify Y and Z? Okay, Y is simply magnesium, which is partially soluble or slightly soluble, and P is, oh sorry, and Z is definitely a P with +5 oxidation state. So your answer is A. Next one, the three reagents are listed. Okay, we have sodium hydroxide, aluminum hydride, we have water. So which reagent react with pure ethanoic acid to produce ethanoate ions? Okay, what is going to decompose this one? So let's say if it's ethanoic acid, it is going to react with sodium carbonate and it will produce carbon dioxide, salt, and carbon dioxide. Wait, let me write carbon dioxide, salt, whatever. Here we have sodium ethanoate and water, and we know that salt can easily, if it's sodium, it can easily decompose while it's present in water, and definitely we have water, so it's going to decompose into sodium ions and into ethanoate ions. So yes, this one is, first one is correct. Number two, it's not going to react with this one because it's a carboxylic acid, and if we dissolve it in water, it is going to produce ethanoate ions. That is for very sure, along with hydrogen ions. So answer is 1 and 3. So B is our answer. Next one, complete combustion of compound T produces carbon dioxide and water. Okay, let's see. This T is producing carbon dioxide and water. Compound T produces steamy fumes with PCl5. Okay, it's reacting with PCl5 and produces the fumes of some chloride compound. So a compound T does not give any visible product with 2,4 DNPH. 2,4-GNPH, and keep in mind this is used to test either aldehydes or ketones. So let's say they are saying that there is no visible result, means this aldehyde and ketone is absent. So, what does question say? States, it states what can be deduced with certainty. Like what is for very sure. Okay, we cannot deduce whether it's a carboxylic acid, hydrocarbon, or alcohol, but we can say that it's not aldehyde or ketone. So our D option is correct. It's definitely not an aldehyde. That is for very sure. Number 27, information from carbonyl compounds is given. Compound X reacts with, okay, LALHF4 to react to produce secondary alcohols. Okay, this is one point. Number two, it reacts with alkaline H2 to give yellow precipitates. Okay, what can be the correct answer? So very, you need to remember the secondary alcohol are produced from ketones. So we have two options. This A and C are definitely not going to be the one. So it can be butanol, it can be pentanone. Threnone means it's present on the third position. So I doubt if this is, because there are three carbons. So three carbon, if even if you change the position, there can be only two position, and it's not going to make the secondary alcohol. The secondary alcohol can be made by this butanone, because there are four carbons, and we can shift position here and here and one and here, so it can be butanol. Or if we have more options, like if there are more number of carbons, definitely there are more chances, so we'll choose that. So if we are going to choose pentanone, no, it's not going to be the one. Next one, an organic compounds J react with excess of sodium to produce an organic ion with a charge of -3. Okay, so this one is positive and it's reacting with something. And so wait, it's +1, so let's consider this X organic ion, it has a charge of -3. Okay, now the next one says J's react with excess of sodium hydroxide, let's say sodium hydroxide, and it has a charge of -1, means it has a potential of having -1 charge when it's a neutralization reaction. So what could be our answer? So let's say what can be the structural formula. This first one is carboxylic acid, yeah, aldehyde, and then we have aldehyde. So no, we are not going to consider aldehyde. Let's consider this sorry, the carboxylic acids. So which one is the correct formula? So let's make this one. This is CH2 and we have OH, then we have CH with OH, then we have what do we have? We have CH2 and then we have CH2OH. Okay, so let's see what's in there. So we say that if this one is going to be replaced when reacting with sodium hydroxide, it would get a charge of -1. Let's consider the next one. So it's almost similar with one differentiation, which is, I guess there's, okay, here we have CHO2. So this is not correct, definitely. It's not logically correct. So our answer would be A. So here you have to be very smooth with making the structures of elements. Only then you'll be able to understand whether which is the correct answer, which is not. Next one, 29. Which formula represent the organic compound by the formation of propanoic acid? And we have methanol. Okay, simple. This one is carboxylic acid and an alcohol. So it's whenever they react, there is formation of ester along with the removal of water. It's a condensation reaction. So in the presence of concentrated sulfuric acid, so what formula, what is going to form? Let's write this propanoic acid. This is CH3, CH2 and COOH, and we have what we have methanol. We have CH3 and OH, so this is going to eliminate as um, water. So we have H3C, CH2, and we have C double bond O, and then we have O, and then we have CH3. So let's see, CH3, CH2, CO, CH3. I guess this 29th one seems to be correct. Let's, okay, sorry. There is a single O that I missed. Okay, then next one is CH3, CH2C. Then we have O2. Yes, there is O2 present. So this is the formula. This is your answer. Number 30th, we have a structure isomerism and stereoisomerism should be considered while answering this question. So we have 2,5-dibromo hexane is heated under reflex with ethanoic KOH. So it's a better elimination. How many isomeric compounds are formed with molecular formula C6H10? Let's do this. So we have 6 carbons, 1, 2, 3, 4, 5, and 6, and we have what we have bromine at this position number 2 and then position number 5. Rest we have to write the hydrogen. So when it reacts with potassium hydroxide, what is going to happen? This is going to remove the 2 HBr, and there is development of 2 double bonds. So it's C, and again a double bond, then C and C, then a double bond, and then C. So let's write hydrogen. It's one, it's one, it's one, it's one, and again CH3. So we have a total of 10 hydrogen. So yes, this one is the formula that we are going to make. So how many isomers can be formed? So this is first one. Second one, you can change the position to this one. It will become 2 5, it can become 1 5, it can become 1 3, it can become 2 4. So it's a challenge for you now. You have to make the isomers of this hexadiene, and just tell me the answer how many isomers you can form. I'm telling you answer, it's six, but you need to make it by yourself. And see you in the next video. And do tell me if you want me to make the isomers for these for you, and I'll be sharing a video with you. So stay tuned and follow me on Facebook, on Instagram, and YouTube, of course. And see you in the next video. Goodbye. Yellow.